Section 1. The Upward Urge Understanding Lift. We've all looked up at a jumbo jet and wondered, how does that thing stay up there? The answer, in a nutshell, is lift. Lift is a force that opposes gravity and pushes an aircraft upwards. It's generated by the wings. Think of a bird's wing or an airplane's wing. Notice how they're curved on top and flatter on the bottom. This shape is crucial. When air flows over the curved upper surface, it has to travel faster to catch up with the air flowing over the flatter bottom surface. This difference in speed creates a difference in air pressure. The faster moving air on top creates lower pressure, while the slower air underneath creates higher pressure. This pressure difference generates lift, pushing the wing and thus the plane upwards. This principle, known as Bernoulli's principle, is fundamental to understanding flight. It basically states that faster moving air creates lower pressure. This principle is not only essential for airplanes, but also explains why a curveball in baseball curves, or how a sailboat can sail against the wind. Section 2. Gravity's pull, Earth's unseen tether. We all know gravity. It's the force that keeps our feet on the ground. It's also the force that airplanes have to overcome to achieve flight. Gravity is a constant force pulling everything towards the center of the Earth. In the context of flight, gravity acts as a counterforce to lift. For an airplane to take off, the lift generated by its wings must be greater than the force of gravity pulling it down. This constant battle between lift and gravity is what makes flight possible. When a plane is cruising at a steady altitude, it means that the lift generated by its wings is perfectly balanced with the force of gravity. Understanding this basic principle is key to understanding the challenges and triumphs of flight. Section 3. Thrust, pushing forward, taking flight. We've talked about lift, the force that counters gravity, but how does an airplane get moving forward in the first place? That's where thrust comes in. Thrust is the force that propels an aircraft forward. Thrust is generated by the plane's engines. Whether it's a propeller engine or a jet engine, the principle is the same. They create a forward force by pushing a mass of air backwards. This push propels the plane forward. Think of a rocket launching into space. It expels hot gas out its back, which propels the rocket upwards. Similarly, an airplane engine expels air backwards to create forward motion. The more thrust an engine generates, the faster the plane can go. This is why powerful jet engines are needed for larger aircraft or for achieving high speeds. Section 4. Drag, the resistance of air. Imagine trying to run through water. You feel resistance, right? That's drag. Air, like water, creates resistance. This force, called drag, opposes the motion of any object moving through it. Drag is caused by the friction between the air and the surface of the aircraft. The smoother and more streamlined the shape of the aircraft, the less drag it will experience. This is why airplanes are designed to be aerodynamic. From their sleek fuselages to their swept-back wings, every aspect of their design is optimized to minimize drag and improve fuel efficiency. Understanding drag is crucial for designing fuel-efficient and high-performing aircraft. Imagine trying to fly a brick. It wouldn't get very far. Minimizing drag is all about creating the smoothest possible journey through the air. Section 5. The Balancing Act, how planes stay up. We've now learned about the four main forces acting on an airplane: lift, gravity, thrust, and drag. But how do these forces work together to keep a plane in the air? The answer is balance. For an airplane to maintain a steady flight, all four forces must be balanced. Lift must be equal to or greater than gravity, and thrust must be equal to or greater than drag. When these forces are balanced, the airplane can fly straight and level. To climb, the pilot increases lift or thrust. To descend, they decrease lift or thrust. Turning is achieved by adjusting the control surfaces on the wings and tail, which alters the lift distribution. It's a delicate dance of forces, but one that pilots train rigorously to master, ensuring safe and controlled flight. Section 6. Beyond the basics, different types of aircraft. When we think of airplanes, we often picture the typical commercial jetliner. But the world of aviation is vast and diverse, with a wide array of aircraft designed for different purposes. There are helicopters, which use rotating blades to generate lift and can take off and land vertically. There are gliders, which have no engines and rely solely on lift and gravity for flight. And there are military jets, designed for speed and maneuverability. Each type of aircraft has its own unique design and flight characteristics, tailored to its specific purpose. From the massive cargo planes that transport goods across continents to the nimble drones used for aerial photography, the variety of aircraft is a testament to human ingenuity. The science of flight is constantly evolving, with new designs and technologies pushing the boundaries of what's possible in the air. Section 7. The wing, a marvel of engineering. The wing is arguably the most crucial component of an airplane. It's the primary surface that generates lift, making flight possible. But have you ever stopped to appreciate the engineering marvel that is an airplane wing? The shape of the wing, known as an airfoil, is carefully designed to optimize lift. Its curved upper surface and flatter lower surface create the pressure difference that generates lift, as we discussed earlier. But the wing is more than just a curved surface. Inside, it's a complex structure of ribs, spars, and stringers, all designed to provide strength and rigidity while remaining lightweight. The skin of the wing is also carefully engineered to be smooth and aerodynamic, minimizing drag. The engineering of an airplane wing is a testament to human ingenuity and our understanding of the principles of flight. It's a marvel of design that allows us to soar above the clouds. Section 8. The science of soaring: how birds fly. Long before humans took to the skies, birds were already masters of flight. They effortlessly soar through the air, using principles of lift, drag, and thrust just like airplanes do. But their wings are much more dynamic and adaptable. Birds use their powerful chest muscles to flap their wings, creating thrust to propel themselves forward. The shape of their wings, which are essentially airfoils, generates lift as air flows over them. But what's truly remarkable is the way birds can adjust their wing shape and angle to control their flight. They can twist and bend their wings to maneuver through the air, change altitude, and even soar for long distances without flapping. By studying birds, engineers and scientists continue to learn valuable lessons about aerodynamics and flight control, inspiring new designs and technologies. Section 9. Fun fact: the Wright brothers' first flight. On December 17, 1903, at Kitty Hawk, North Carolina, two brothers named Wilbur and Orville Wright made history. They achieved the first successful flight of a heavier-than-air powered aircraft. Their plane, named the Wright Flyer, took off under its own power and stayed aloft for a grand total of 12 seconds, covering a distance of 120 feet. While this first flight may seem short and insignificant by today's standards, it was a monumental achievement that marked the beginning of the aviation age. The Wright brothers' pioneering spirit and their relentless pursuit of flight paved the way for the incredible advancements in aviation that we see today. Section 10. Conclusion: the enduring magic of flight. From the first hot air balloon rides to supersonic jets, the dream of flight has captivated humanity for centuries. Understanding the basic principles of flight: lift, gravity, thrust, and drag helps us appreciate the science that makes this dream a reality. Whether it's the sleek design of a passenger jet or the effortless soaring of a bird, flight continues to inspire awe and wonder. It's a testament to human ingenuity, our understanding of the natural world, and our unyielding desire to explore the skies above. So next time you see an airplane soaring overhead, take a moment to appreciate the incredible science and engineering that makes it possible. It's a marvel of human achievement and a reminder that the sky is not the limit when it comes to our dreams and aspirations.